Welcome to video lecture on differential equation. I hope all of you are following the previous video lecturers. If you have any doubts, you can contact me on Google Learning or WhatsApp app. Today the topic is the Cauchy-Euler equation. It is completely different from the previous differential equations what we learned. Okay, uh, the equation of the form, it is in the form of an x power n dn y by dx. That means derivative of n times. Okay, plus an minus 1 x power n minus 1 dn minus 1 y by dx n minus 1. So on a1x plus dy by dx plus a naught y is equal to q of x. Here an minus 1 a naught, that is a0 a1 an, all are real numbers. Suppose the differential equation of this form is called Cauchy-Euler equation. Okay, the easiest way to finding means here x power n means here nth derivative, x power n minus 1 means n minus 1th derivative, x means one time derivative, here x power 0, so there is no derivative. So like that we have to recognize the Cauchy-Euler differential equation. Today we are going to derive the formula for second order Cauchy-Euler equation. So the second order will be a square x square d square y by dx square plus a1x dy by dx plus a naught y is equal to q of x. Okay, so here the approach is what we have to means we have to change the independent variable x into t. Okay, now what we are going to do, we are changing the independent variable x into t. So here take x is equal to e power t, then ln of x or log x is equal to t. That is, if I differentiate both sides, ln of x differentiation is 1 by x and t is dt by dx. So what we are going to do means here we are going to do dy by dx in terms of dy by dt, d square y by dx square in terms of dt by or d square t by d square y by dt square. So based on this one we are going to change dy by dx. What is the dy by dx here? See, in the beginning problem, y is a function of x and x we are assumed is a function of t. So dy by dx will be dy by dt into dt by dx. So what is dy by dt? We don't know. Just leave as it is. And dt by dx, here we have found. Why? Because ln x equal to t, ln x equal to t, so dt by dx is equal to 1 by x. Next, d square y by dx square, it is the product function. So first we are differentiating this term, that is 1 by x into d by dx of dy by dt plus d by dx of 1 by x into dy by dt. 1 by x in the next step, 1 by x as it is. See here, again, it is dy by dt. That means once again we have to do with respect to t like this here. Dy by dt into dt by dx, like that. Dy by dt into dt by dx. So is already one derivative is there. So it becomes d square y by dt square. And dt by dx will be 1 by x minus 1 by x square dy by dt. As it is have done. So here I am taking 1 by x square common, then d square y by dt square minus dy by dt. So what I need in the problem, the differential equation is you may see here x into dy by dx, x square into d square y by dx square. So first we are finding here x into dy by dx. So here dy by dx is equal to what we got, dy by dt into 1 by x. If I cross multiply x here, x into dy by dx is equal to dy by dt. So x into dy by dx is equal to dy by dt. So what is here? X square d square y by dx square. From this d square y by dx square x square, if I take cross multiply, x square d square y by dx square is equal to d square y by dt square minus dy by dt. So all the values we got. Now the problem, dy by dx change it to dy by dt. Here d square y by dx square change it to d square y by dt square minus dy by dt. So in the previous problems, we assumed capital D as d by dx. So to avoid the confusion, we are assuming here d1. What is the d1 means? dy by dt. In Cauchy, I remember in Cauchy-Euler equation, d1 means dy by dt. Okay. In some of the books like S. Chand, generally students follow, in that book they have given theta. Whatever it may be, both are right. So x dy by dx is equal to d1 and x square dy square by dx square. See here d square y by dt square, that means d1 square, dy by dt, that is d1. So in simplified form I have written d1 into d1 minus 1. We have not solved for x cube, but directly we are writing x cube d cube y by dx cube is equal to d1, d1 minus 1, d1 minus 2. Okay, based on these information, we are going to solve the problems involved in Cauchy-Euler equation. Okay, remember in the Cauchy-Euler equation, one important thing is we'll change the dependent variable x to t. Okay, remember that one. But in the final answer, again we have to change t to x, write the solution in terms of x only. So the first one, x square d square y by dx square plus x dy by dx minus 4y is equal to x square. Easily we can confirm that it is Cauchy-Euler equation. Why? Because see here, x square d square y by dx square, x dy by dx. There is no x power 0, you may assume x power 0 and 0 derivative. Okay, so like that. So what is the procedure in this type of problem? X is equal to e power t, then ln x is equal to t, and we assuming just now I have said d1 is equal to d by dt. So then the differential equation can be written as here x square d square y by d square means d1 into d1 minus 1 plus this one value is d1 minus 4 into y is equal to x is equal to e power t. So x square becomes e power t whole square. If I simplify, d1 square minus d1 plus d1 minus 4 into y is equal to e power 2t, and minus d1 plus d1 gets cancelled. So auxiliary equation, just substitute m instead of d1, it becomes m square minus 4 equal to 0. So m will be plus or minus 2. So the yc will be c1 e power t2 plus c2 e power minus t2. Why? Because I got two values, 2 and minus 2, real and distinct. Here why I have made star mark means generally students don't write the answer in terms of t only, but the question is in terms of x. So again we have to change t to x. Actually here, see, here x is equal to e power t, e power 2t means it becomes x squared. So x squared. E power minus 2t means it becomes x power minus 2. So this is our yc. Let's move to the yp. What is our yp? Yp 1 by d1 square minus 4 e power 2t into 1. Why I have written 1 directly and why I am not substituting with e power at means if I substitute 2 value instead of d, it becomes 4 minus 4 0. So for that purpose I have applied the formula of this one. 1 by f of d e power ax into v is equal to e power ax by 1 by f of d plus a into v. So here a is 2. So e power 2t. Instead of d1 I am substituting d1 plus 2 whole square minus 4. So e power 2t. If I expand this one, d1 square plus 4d1 plus 4 minus 4 gets cancelled. So this is in terms of x. 1 means x power 0. So we follow the method where x power the method in which x power n is there. So I am taking 1 by 4 fd1. Why I am taking like this means it becomes in the terms of 1 plus x whole power minus 1. See here, 1 plus x whole power minus 1 is 1 minus x, so on. We can take common. So for that purpose, d1 square plus 4d plus 1 e power 2t by 4d1. If I bring this one to the numerator, 1 plus d1 d by 4 whole power minus 1. If I expand that, e power 2t by 1 plus d1, 1 plus, I have written something, why I am writing directly 0 means that is d1 plus something, and here value is 1. Derivative of 1 is 0. That's why I'm not writing. Just I'm writing 1 here. So e power 2t by 4. Here 1 by d1 means integration. Here d1 means derivation with respect t. So 1 by d1 means integration with respect to t. So it becomes 1 integration of 1 will be t. So e power 2t by 4. E power 2t becomes x square, t becomes ln x. If I interchange t terms into x. So the value y is equal to yc plus yp and y is equal to c1x square plus c2x power minus 2. The yp is x square ln x by 4. Remember this one. Again we have to change t terms to x. And one more problem we are going to discuss now. That is x square d square y minus x dy minus 3y is equal to x square log x or ln x. Easily we can confirm that this is Cauchy-Euler equation. Why? Because x square d square xd. Okay. So what is the procedure? X is equal to e power t, ln x is equal to t, and d1 is equal to d by dt. X square d square becomes d1 into d1 minus 1. What we have derived in the problem? Minus xd means d1 minus 3 into y is equal. X square means e power 2t here. X square e power 2t. Log x or ln x, that is equal to t. So d1 square minus d minus d1 minus d1 minus 2d1 into y is equal e power 2t into t. If I write auxiliary equation, m square minus 2m minus 3 is equal to 0. I'm simplifying, I'm not explaining this one. This is a simple process. I have got minus 1 comma 3 are the roots. So the auxiliary equation will be c1 e power minus t, c2 e power 3. Remember, again we have to change these t values into x. So c e power minus ln x, c2 e power t means x, e power 3t means x cube. E power minus ln x means I can interchange x and e here. It becomes x power minus 1. So c2 x cube. So yp will be 1 by d1 square minus 2d1 minus 3 e power 2t into t. Just the same the formula what we have applied earlier. I have written formula also here. E power 2t if I take, instead of d I have to substitute d plus 2. Sorry, d1 I have substitute d1 plus 2. So d1 plus 2 whole square minus 2 into d1 plus 2 minus 3 into t. If I simplify this one, I have got d1 square plus 4d1 minus 2d minus 3. Again I have to make in terms of 1 plus x. So for that purpose I am taking minus 1 by 3 common. So minus 3 common, I have written it as minus 1 by 3. So 1 plus d1 square minus 3. 4d1 minus 2d is 2d by minus 3, 2d1. If I bring this one to the numerator, minus e power 2t by 3, 1 minus d1 square plus 2d1 minus. The same formula what we are applying here, 1 minus x whole inverse is 1 plus x square. No need to write all these terms. See, why? Because here x square means derivative 2 times. If you differentiate 2 times, t becomes 0. So we'll write only d terms. We don't write the d square terms. So if I expand this one, d1 square by 3 plus 2d by 3 plus here d1 square by 3 plus 2d by 3 whole square term will get, but we are not writing. Anyhow it becomes 0. So it becomes t, d1 square means is 0, 2d by 3 means differentiation of t with respect to d is 1. So 2 by 3. So e power 2t means x square by 3, t means ln x plus 2 by 3. This is our yp. So y is equal to yc plus yp. So I am writing yc here and yp. Okay. And one more problem is there in Cauchy-Euler equation. In the next class, we will discuss the problem and we jump to Legendre equation. That is also extension to the Cauchy-Euler equation. Here x power n term is there. In that Legendre equation, ax plus b whole power n terms. Okay. And my request is stay home, stay safe, don't go anywhere and follow the video lectures.